Good morning, good afternoon, good evening. This is Mr. Payne bringing you Unit 6, Lesson 4, Exponential Functions. So far, we have concentrated on linear functions, which are characterized by having a constant rate of change. In the last lesson, we looked at exponential growth and decay, knowing that growth is increasing rapidly and decay is going down or decreasing rapidly. In this lesson, we will more formally introduce the concept of exponential functions. Exercise number 1. Let's consider the exponential function f of x equals 8 times 2 raised to the x power. Answer the following. So all we have to do is continue on plugging in, substituting our numbers in. Our 2 is going to go in for the x, so it's going to say 8 times 2 raised to the second power. 8 times 2 to the second power is 4, which is going to give me 32. Double I. 8 times 2 raised to the 0 power. Well, we have to recall from the lessons prior that anything to the 0 power is 1. So 8 times 1 is going to give me 8. Triple I here, f to the negative 1. So I'm going to have 8 times 2 raised to the negative 1 power. Remembering that we don't like negative exponents, I'm going to say, okay, 8 times, now I'm going to take that 2 raised to the negative 1 power, I'm going to put it over 1 over 2 to the first power. So 8 times 1/2 ultimately is going to give me 4. Now we're going to go to B, and you know what the word average rate of change stands for. Average rate of change means that we're going to use our formula that we've been using for 2 years now, y2 minus y1 over x2 minus x1. Over the interval, negative 1 to 0. So we're going to go ahead and find my negative 1, which is triple I, which is going to give me 4, and compare it to 0. So negative 1, the point that we're going to use is negative 1, comma 4, and we're going to use 0, comma 8. I still want you to identify your points, x1, y1, x2, y2, so that we can move forward from there. Now let's plug our numbers in correctly. I have 8 minus 4, and I have 0 minus a negative 1. 8 minus 4 is going to give me 4. 0 plus 1 is going to give me 1. So now my rate of change is 4 between that interval. C. We are going to find the average rate of change again. So we're going to write down our formula. y2 minus y1 over x2 minus x1. Now my interval is going to be from 0 to 2. So my 0 is going with 8, and my 2 will be going with 32. So we're going to now label my points, x1, y1, x2, y2. And let's plug our points into the proper spots. It's going to be 32 minus y1, which is 8, x2, which is 2, minus 0. So I'm going to get 32 minus 8, which is going to give me 24, over 2, which reduces down to 12. So my average rate of change between this interval is 12. So let's read D. What does comparing answers from B and C tell you about this function? Well, I have an average rate of change of 4 for the interval negative 1 to 0. And for the interval from 0 to 2, I have a rate of change of 12. What does that tell me? Remember that a linear function is a constant rate of change. And what is this reinforcing? That the rate of change for exponential functions is not constant. So let's write that in for D. Exponential functions, expo, and I'm going to abbreviate it, exponential functions does not have a constant rate of change. Does not a constant rate of change. I want to take the time to reinforce these skills. A general exponential function has the form of y equals a times b to the x power, where a is my y-intercept, and another word for y-intercept is my starting point, my starting value. And my b is the base, or the multiplying factor. What am I multiplying by? Sometimes it's known as my growth factor, but I want to be careful on that because we're not always growing. Sometimes we are also decaying. Okay, let's evaluate g of 0. So that means I'm going to have g of 0 equals 54 times 1/3 raised to the 0 power. Well, if you remember, what is anything to the 0 power? G of 0 is going to equal 54 times 1, which is going to equal just 54. So this here is my y-intercept. So g of 0 is my 54. That's what that proves, that is my y-intercept. So without using your calculator, determine the values of g of 1 and g of 2. Well, g of 1 is going to be 54 times 1/3 raised to the first power. And that's going to give me an answer of 18. And then I have 54 times 1/3 raised to the second power. Well, if you wanted to go ahead and now, remember, you can use your calculator to do 1/3 raised to the second power, or you can type that into your calculator. Or you can say, all right, 54 times 1 squared is 1, 3 squared is 9. So we kind of distribute that square into both the numerator and the denominator. And 54 times 1/9 will give me 6. So now, using your graphing calculator, sketch a graph of the function using the window -2 to 4 and -10 to 100 and mark your y-intercept. I will do this with you in class. So we will talk about C in class and we'll use my graphing calculator. So why is the exponential function always decreasing while the one in exercise 1 is always increasing? Well, let's talk about that. Increasing versus decreasing exponentials. We're going to really focus in on my b for right now. If my b is greater than 1, so that means it's a whole number that's greater than 1, I will be increasing. If my b is less than 1, we will be decreasing. So when I say less than 1, what I mean by that is that we're going to be working with the numbers between 0 and 1, not including 0. So we're talking about my fractions. So 1/2, 1/3, 2/5. If I have a fraction that is less than 1, my b, if my b is a fraction, then I will be decreasing or I will be decaying. Let's do some quick practice here, identifying the y-intercept and telling whether it is increasing or decreasing. Let's go to A. My y-intercept, my A equals 8, and that's my y-intercept, and my B equals 2/3, so therefore that represents something that is decreasing. Let's go to B. My A, or my y-intercept, is 125, and my B is 1.5, so that is greater than 1, so therefore I am increasing. C, my A is 56, and my B, which is my base or my multiplier, if I did 3 divided by 2 in a calculator, you would see that it is greater than 1. So 3 over 2, I know it is written as a fraction, but 2 over 2 is 1 whole, so 3 over 2 is greater than 1, so therefore I am increasing. Let's do exercise 4. Find the equation of the exponential function y equals a times b to the x power form for the function given in the table below. You guys have done a fabulous job highlighting your y-intercept. My highlighted my y-intercept is right here. because that is where my 0 is. So my y-intercept, my a, equals 10. And now when I say, okay, how do I go from 10 to 30? How do I go from 30 to 90? How do I go from 90 to 270? It is times 3. So my b is going to be times 3. So if I were to write my formula, y equals 10 times 3 raised to the x power. If you have any questions, please bring them with you to class. Thank you very much.